Alright, you are welcome to our lesson number 4, chemistry. Now in this lesson we are going to calculate masses from a stoichiometric equation. So this one is stoichiometric equation. So what is a stoichiometric equation? A stoichiometric equation is this equation with well balanced reactants and products. Remember, an equation has the part of reactants, reactant A reacting with B, giving us product A and B. So this is the side of reactants, this is the side of products. So in what we call a stoichiometric equation, the reactants and the products must be well balanced. So from the well balanced equation, we can compare and convert what is required to be obtained. Remember, this is revisionug.com. We provide education in its simplicity. We offer or we provide well organized notes, quizzes and examinable tests. Please do follow, share, subscribe. Okay, so let us come back to what we are going to do today. A stoichiometric equation, as I've said earlier, it is that equation with well balanced reactants and products. Let us take an example of a simple equation. For example, I'm having sodium. This is a solid reacting or burning with oxygen, which is a gas. I'm going to form a sodium oxide, which is a white solid. So when you look at these reactants, now they have produced one product. So sodium, it is one. We have one atom. This way there are two, so I'm going to put here 2. The moment I put a 2 here, it means that oxygen here I have 2 atoms, then this way I have only 1 oxygen atom, so it is not balanced. So what am I going to do? I'm going to put a 2 here. The moment I introduce a 2, sodium atoms, they're going to raise to a 4 and oxygen are going to be 2, then which means that now my sodium is out of balance. Then I'm going to add a 4 there. Therefore, this equation is a stoichiometric, so it is well balanced. So how do we use this stoichiometric equation? We are saying that 4 atoms of sodium or 4 moles of sodium react with 1 mole of oxygen to produce 2 moles of sodium oxide. So that's how we use a stoichiometric equation. Alright, so in this lesson you have to be well versed with balancing, completing the equations. I think you have that skill or the concept. Let us get started with our first example here. Number 1, they are telling us that calculate the loss in mass when 10 grams of calcium carbonate are heated to a constant mass. So this question is a little bit of logical. They are telling us that there is loss in mass when we heat calcium carbonate, and there are 10 grams that were heated. So what is required of you is to first write the equation correctly. So that is calcium carbonate. So this is calcium carbonate. It is a white solid. What is taking place here? It is being heated. On heating, what are we going to get? So it's going to lose carbon dioxide in form of gas automatically. Then you are going to remain with white solid, that is calcium oxide, and then plus the carbon dioxide, which is a gas. This is a solid. Therefore, automatically this one is lost, this one is going to remain there. So after writing or completing the equation, what next is to balance it. So calcium is atom is 1 here, even 1 here. Then carbon atoms we have 1, and also here it's 1. Oxygens, there are 3, so we have this 1 and 2, so there are 3. So the equation is now stoichiometric, it is well balanced. Then after that, if we put what is given, so they are giving us 10 grams there. Now from the standard equation, we are going to use what we call the relative formula masses of different products or reactants that are cited out in a question. For example, we are comparing calcium carbonate and the loss in mass. What is that one? Carbon dioxide. Therefore, calcium carbonate we are getting is RFM, whereby calcium it is a 40, then plus 12, then plus 48. 48, that is oxygen, because there are 3 atoms there. So we are adding 40, we add it to a 12, then plus 48. Oh, sorry, this is a 40, then 40 plus 12, then plus 48. 8, so we are coming up with 100. So 100 grams. Then here carbon dioxide, this is going to be 12 plus 2 by 16, which is 12 plus 32, which is giving us 44 grams and 100 grams, meaning that at a standard level 100 grams of calcium carbonate, when heated, they lose 44 grams of carbon dioxide. Therefore we put it in writings and say 100 grams of calcium carbonate, when heated, they lose 44 grams of carbon dioxide. Then in this question they have not given us the whole 100, they have just given us a portion, that is 10 grams. Then how about if I heat 10 grams of the calcium carbonate? How many grams of carbon dioxide am I going to lose? So this is 10 grams out of 100 grams by the 44 grams of carbon dioxide. So gram by gram, so a 0 by 0. So we are having here 1 out of 10 times 44 grams of carbon dioxide. So we compute that one. So this is going to be 1 divided by a 10 gives us that one, then multiply it by 44. So the loss is 4.4 grams. So calculate the loss in mass. The mass which was lost, it was 4.4 grams of carbon dioxide. Right, let us get another example here. So to remind you, when you are to do these numbers, you have to be versed with the RFM, and again writing the equation and balancing the equation correctly. Then you start comparing the masses with what you have balanced there. Now this question number 2, they are telling us that copper 2 oxide is reduced by hydrogen according to the equation. So remember, reduction, this is when we remove hydrogen, or we remove oxygen from a given compound, or we add hydrogen to a given compound, or it is the loss of is the gain of electrons, sorry. Then let us look at this copper 2. Remember, copper 2 oxide is a black solid. It is a solid. When it was reacted, or when it reacts with oxygen, hydrogen, we are going to have the reduction reaction, where we are going to form a brown solid of copper plus a colorless liquid, which is water. So this is the equation. Let us now look at this question, equation, whether it is balancing. Copper 1 atom, right? Oxygen 1 atom, hydrogen, there are 2 atoms. All right, the equation is just fully balancing. Then we go for RFM. Now what are we going to compare? Calculate the mass of copper formed. So we are comparing the copper 2 oxide and the copper formed. Now copper 2 oxide, we are having copper as 63.5 plus oxygen, which is 16, then we are coming up with this is 63.5 then plus the 16, sorry, this is plus 16 here. So this is 79.5 grams. Then copper, this copper, it is 63.5 grams. Then we start comparing at a standard level, meaning that 79.5 grams of copper when reduced by hydrogen, they produce 63.5 grams of copper. So we put it in 2 writings. 79.5 grams of copper 2 oxide when reduced produce 63.5 grams of copper solid. Then how about 4 grams? If we just reduce 4 grams of copper 2 oxide, then they are going to give us 4 grams all over 79.5 grams times 63.5 grams of the copper solid there. Then what are we having there? That is we are having 4 divided by 79.5 gives us that one. Multiply it, divide it by let me repeat this one. It is 4 divide by 79.5. This one gives us that one. Then multiply it by 63.5. So what do we get? So we get 3.194 grams of copper that will be formed. Right. So our example number 3 here says capture the mass of ammonium chloride that will just react completely with 14.8 grams of calcium hydroxide. So let us now have this equation written down. So we are having ammonium chloride. So this is ammonium chloride, right? It is a solid reacting with the calcium hydroxide here, which is also a solid. What are we going to form? We are going to form a calcium. We are going to form calcium chloride there, which is a solid, and then we form ammonia gas, and also we form water there, which is a liquid. Then we start balancing the equation. So nitrogen here, we have nitrogen, hydrogen, chlorine, then we have calcium, then we have oxygen. Then nitrogen here we have 1, then hydrogen we have these 4 and these 2, so hydrogen is 6, then chlorine is 1, then calcium is 1, oxygen is 2. Then we follow the same order. We have nitrogen, we have hydrogen, we have chlorine, we have calcium, then we have oxygen. The nitrogen it's 1, then hydrogen we have these 3 and these 2. Now they become 5. Then chlorine we have this way, they are 2. If they are 2, then calcium it's 1, then oxygen we are going to have 2 of them. So what is out of balance? Oxygen is balancing, calcium is balancing, chlorine is not balancing. If chlorine is not balancing, we are going to put a 2 here. The moment we introduce a 2, then nitrogen is now going to be 2 this way, or hydrogen 8 plus this one, they are going to become 10, and chlorine now they are going to become 2. Then automatically nitrogen is not balancing, there are 2 there, and calcium and oxygen is not also balancing there. Chlorine is not also balancing there. So here nitrogen they change it to 2, then 6 plus these 2, there are 6 here plus a 2, now they become 8. Now if they become 8, then nitrogen 2, these are 8. So what is not balancing? Chlorine is balancing, oxygen is not balancing, hydrogen is not balancing. So what are we going to do? We just introduce a 2 here. The moment you put a 2 here, then oxygen is 2, then these are 4, then 4 plus a 6, then they become 10 automatically. Now the equation is balancing. Therefore, from this equation, what are we comparing? So we are looking at mass of ammonium chloride that will just react completely with 14. So we are looking at ammonium chloride and calcium chloride. So at a standard level, let us get the RFM of ammonium chloride. So we have nitrogen, which is 14, then plus hydrogen, which is 4, then plus chlorine, which is 35.5, and all of this one because there are 2 molecules here. Therefore 2 into, then let us compute this one. We are having that is 14 plus 4, then plus 35.5. What's the answer? 53.5. Then double it times 2, we are getting 107. So all of this one is giving us 107 grams. Let us get for calcium hydroxide here. We have calcium, which is 40, plus oxygen, which is 32 now, and 2 hydrogens. So if we add that 40 now 40 plus 32, then plus 2, right? Yes. Then this one is giving us a 74 grams. It means that 107 grams of ammonium chloride react completely with 74 grams of calcium hydroxide. How about if we use only 14.8 grams of ammonium chloride? We are going to get 14.8 out of 107 times 74. Then what are we going to have here? So we are going to have 14.8 divided by 107, right, is equal to, then multiply it by 74. So what is the answer? We only get a 10.23 grams of calcium hydroxide. Right, let me hope that we are still together. This is revision.com. In this lesson I'm going slowly simply because there are very many aspects we have to combine in order to come up with the correct answers here. So they are telling us that what mass of iodine is in 5 grams of lead iodide. Now lead iodide, let us first write lead iodide. This is how we write it. Then we get the RFM of this lead iodide. So lead, then plus iodide there, then lead is 207 plus 2 times 127, then 207 plus let us get this one, 127 by 2, the answer is 254, and then add it to 207, the answer is 461 grams. Therefore 461 grams of lead iodide, they contain how much iodine? They contain this iodine contain 254 grams of iodine. Then how about 5 grams? 5 grams of lead iodide will contain now will contain 5 grams out of this is a 6, sorry, 461, and then times 254 grams of iodine. So let us compute this one. This is 5 divided by 461 gives us that one. Multiply it by 254. The answer is, we just get 2.75 grams of the iodine there. Right, let us now look at our last example here. Let me hope that you've been moving with me during this lesson number 4. So this one, our last example says aluminium reacts with iron to oxide according to the following equation. This is aluminium. So here we have this arrow like that. So iron to oxide reacts with aluminium to produce aluminium oxide and iron. So what mass of iron 2, sorry, not iron 3, what mass of iron 2 oxide would be required to produce 10 grams of iron? Now let us first write our equation just here. Then this is iron 2 oxide reacting with 3 atoms or 3 moles of aluminium, which is a solid. They are all solids, to produce 1 mole of aluminium oxide and 2 moles of iron. So what are we comparing? We are comparing iron and iron 2. So let us get the RFM of iron 2. So this is 56 times 2 and then plus 48, right? So what are we having then? 56, this is a 12, you put here 10, 11, then plus 48. Let us add that one. So by so we add there plus, this is plus 48. 48, what are we having? so this is 160 grams. Then come to iron 2, then iron 2 here, it is going to be at 2 times 56, which is going to give us 112 grams. Therefore 160 grams of iron 2 oxide, when reacts with aluminium, will produce 112 grams of iron. Then how about now 10 grams of iron, then meaning that 112 grams of iron they come from 160 grams of iron 2 oxide. Then if I need 10 grams of iron, so how much iron 2 am I supposed to be with? So let me write it here. So from here it's going to be 10 grams over 112 grams, then times 160 grams there. So gram will go with the gram. So here we are having 10, so this is 10 divided by 112, this is giving us that one, then times this is 10 times 160 gives us that one, divide it by 112, we are having 14. So you'll need 14.28 grams of iron 2 oxide. So from here down the video we are having this task. So there are two simple numbers. Please try to do them and see whether you've understood to calculate masses using the stoichiometric equation. Keep it with revisionug.com. Now this equation within this assignment, the equation is missing calcium hydroxide. According to this equation, calcium hydroxide here, which is a solid, reacts with ammonium sulfate here, which is also a solid, to produce calcium sulfate, that is a solid, plus water, which is a liquid, then plus ammonia, which is a gas. So please try to do this task, and in case of any query, in case of any help, please contact our links just below the video. Keep up with revisionug.com.